Okay, so chapter 13, digital forensics. This is going to be a real light overview of digital forensics. We're actually going to do an exercise in your case where you guys are going to get a hard drive and you're going to get some tools to process the hard drive. So that's going to be kind of cool. You'll get to see the digital forensics process in action. At the end of this, you should have a basic outline or an idea of how to keep integrity of digital evidence, suggest probable locations for particular types of evidence, explain how the storage systems work in the computer, describe in broad detail how information is stored on a hard disk, identify, explain hidden sources of information on a hard disk, identify common data, outline the basic universal procedures for examining removable storage media, and then basic logical structures of the drive. All right, so we're going to go through basically what we're going to cover is really the real fundamentals, or what you call the pillars of digital forensics as we go through this. And then the big one in digital forensics is you're not going to change anything on the drive. You can't change evidence. Um, when we take an image, we have to take it from seizure to the final, laying out in front of the jury. That evidence has to stay the exact same, and we have a process for doing that. We'll talk about it a little bit later. And the evidence must stay unaltered, through that entire process. So it's going to sit in the or wherever it is. It has to stay completely pristine. And we do that by imaging the drive. And imaging does not mean that I have a picture. An image is much like a zip file. It's compressed files put into a single file where I save my bit-for-bit copy of the drive. Then I can work with that bit-for-bit copy to find evidence, and I don't have to touch the original drive, which makes digital forensics different than any other forensic modality, because no other forensic modality can replicate the evidence. For example, blood cannot be replicated, DNA can't be replicated, so I can do investigation on it. Where digital evidence, I can do a bit-for-bit copy, and I can replicate that information. So when I'm going out and I'm collecting evidence to make sure I don't have contamination, I got to make sure that I have an appropriate environment or a place to do my analysis. I've got to have somewhere that's basically, clean and dry, and you want as dust free as possible, because forensic computers eat dirt like it's their job. You want to make sure that you have all the tools you need. You want to have screwdrivers, and you want to have containers for the screws, and you want to have static tape or anti-static tape, and things, anti-static bags to put your evidence in. You want to have all the things that you need to have. You need to have a proper lab environment, or if you're in the field, you may not. You may have just a tent, and you do the best you can. You put as many controls in place as you can. The bottom line is you can't change the evidence. So whatever you put in place and whatever you have has to maintain the integrity of the evidence being collected. And then you have to have qualified people. So there's a person that gets up on the stand, and if they're not qualified, you're going to lose evidence in court. You're going to lose data in court, because you're not going to be able to talk to your evidence. So you're going to have to make sure that whoever is on the stand has the qualifications, has the expertise, has never been daubered before, and that means somebody that has been disqualified because they were caught lying in a past proceeding, things such as that. They've got to have the right qualifications for the drive you're doing. If they're an IBM folk and they're doing a case on a Mac, there may be some issues, and you may have to explain, why it is you have any relevant understanding of a Mac when your whole expertise has been in IBM PC. And then we're going to go through the steps of the acquisition. So you're going to basically the acquisition of your data. You're going to have authentication of your data, imaging of the evidence drive. You're going to be wiping the analysis drive, and then you're going to be restoring that information back. So let's talk about the very first one here, which is acquisition of data. So when you're acquiring the data, again, lab is the preferred method. Um, if you can't do it in a lab, or you have an organization that's not lab based, well, then you have to do the best you can. The biggest thing is you've got to make sure you have controls. Um, if I can prove as a defense attorney that you left a hard drive laying out overnight and nothing was there to protect it, I'm going to argue that somebody took that drive and put all the pictures on there and put all the evidence on there against my client. I'm at least going to confuse the jury enough to make them think that you did something wrong, even though you probably didn't do anything wrong. Maintaining control, maintaining that evidence or that chain of custody on evidence is critical to your preservation of your evidence, and making sure that you don't let anything break that chain of custody. Chain of custody is one of the probably one of the leading reasons why evidence gets dropped from court, because you can't prove the chain of custody. And the second one being the warrant was bad. Those are your two big kind of failures in gathering digital evidence. And then you have your authentication. So basically what has to happen is the prosecutor has to be able to get up on the stand, or excuse me, you have to be able to get up on the stand and tell the prosecutor, this is the same unaltered evidence that I grabbed when I was processing the computer. And we do that through a process called hashing. And what hashing is an algorithm that is collected based on the total numerical value of the data gathered in your file. So once it's done the bit for bit copy, it basically figures out what the calculation of all your hex bits, all the hex in your collection is, with the numerical number. It throws it to an algorithm. The algorithm then spits out a 26-digit alphanumeric number, and that 26-digit is your signature. That is your key to that evidence. And if that evidence changes in any way, a space is removed, a period is added, a number is changed, you're going to get a different value, and it's going to be very evident that you changed your evidence. So that's an easy way for the prosecutor to be able to say, no, this evidence was changed. This also allows the investigator to stand up there and say, I can validate that this evidence is correct because my hash value matches from the original hash that I took. Imaging the evidence drive. When you're creating a working copy, again, a lot of people call it the EO1 image, and that's based on the EnCase, which is a very popular forensic tool in our space, but they have the EO1 image. The other most popular method of collection is called the DD, or direct or disk duplicating method. It's a Linux based tool found in most of the freeware, shareware, forensic tools. And a DD image is very easy to create. It's a larger file. It makes a larger image, and sometimes people don't like it because it is such a much larger image. You're going to create basically a bitstream copy. This means you're going to start out at the very beginning of whatever file segment copy, or excuse me, sector or cluster you're working in, and you're going to do a bit for bit copy of all the data across the drive. Logical copies. So if I have the C drive or a D drive or an E drive, and I do a copy of that drive, I'm not going to get all the information. I'm going to do a physical, what they call a physical bit-to-bit copy of that drive. Logical copies do not get data, some of the deleted data, some of the other information out of it that I want. So I want to make sure I do a logical copy of that drive. Or excuse me, I want to do a physical copy of that drive, not a logical copy of that drive. And then restoring. Each step of the analysis protocol has to be performed 5 times with the operating switching disks as needed. This really doesn't happen much anymore. What we do is we present the evidence to the defense attorney. The defense attorney can either say, yeah, I want to put this back into its original form, or the defense attorney can say, I accept this evidence, and they find some other way of getting around it. The worst thing the defense attorney can do is say, yeah, look, my guy's guilty, and here's more proof that my guy's guilty. They're going to go after something that is not so institutional, and EO1 and imaging and lab-based collection is a very, very stable process, and very few mistakes are ever made in that arena. Wiping the analysis drive, we want to make sure when we're wiping the drive, we're cleaning it for our first time use. Some departments recommend that you wipe it every single time that you collect evidence. We don't have to. If you wipe it the first time, set the drive into a clean form. You don't have to wipe it every single time if you're doing EO1 or DD images. If you're doing a direct copy, well, then you do, because you're making a copy of the evidence drive in its raw format over to another drive, basically making a copy of the two drives, and now you have to wipe that drive the next time you use it. But if I put image files on there, it's like putting a bunch of zip files on there. I can create a bunch of zip files, put them on that drive. They're not going to cross migrate. They're not going to commingle. I'm not going to have a lack of validation of my data. I do like to keep cases together. So I wouldn't mix cases. For example, I wouldn't have a bunch of EO1 files on one case and then use that same collection media to hold a bunch of EO1 files from another case. I'd want to keep them segmented and separate. If I'm putting them onto a mass storage drive, they go into their own file folder, etc. And when you're done doing your wipe, you're going to get a report from the tool that wipes it. It's going to tell you how many sectors were cleaned, what the process was, how long it took, all that kind of stuff. So you're going to know that your drive was completely wiped. So that way when you get on the stand, you can say, yep, I started out with a clean device, a wiped drive, and that wiped drive could not have, it's not possible to have cross-migrated data or commingled data on that drive. All right, so when you talk about analysis, you're looking for information. Basically, you're looking for inculpatory and exculpatory. And we talked about inculpatory and exculpatory before. I'm looking for evidence that could set you free, and I'm looking for evidence that put you in jail. I'm not the prosecutor. I'm not the judge. I'm not the jury, etc. What I am is a factual reporter. So my job is to do is to get out there and find evidence or no evidence that of your hard drive. I don't care about you. I'm going to show that there was something on that drive or something not on the drive. That keeps me from putting my bias into a case. And if I have bias, then I'm going to lose evidence in court, because I can't have bias and render an opinion that is going to be considered to be unbiased. And then over analysis, many times you're going to be working on a drive. Prosecutor's going to come in and say, how much child porn have you found? You say, I found X, and he said, that's fine, we're done. It's enough. I'm charging him with that. Sometimes investigators don't know when to quit. They're like, no, let me find this last piece of stuff. Once you get to a point where you have so much evidence against someone, more evidence just isn't going to be helpful, and it's not going to be useful, and may or may not be allowed into court. So, stay within the scope of your investigation. You stay very clear on what it is you're going after and looking for, and then you stay focused. And once you found the inculpatory or exculpatory that shows or disproves that this individual was involved, then you call your prosecutor and say, hey, this is what I got going on. You got to remember, computer forensics is time-based. You're working on a drive. That's not going to be the only drive you have. You're probably going to have 3 or 4, if you're a good investigator, you're probably going to have 3 or 4 cases at a time, and you're going to have to do time management, and you only have so many tools. So you're going to have to be very clean and clear with the way you process or work through your evidence. So when we talk about storage systems, we talk about 2 different types of storage systems. You have volatile and non-volatile. The biggest thing to remember here is a volatile system. When you pull the power cord on the back of the computer, your file system goes away. So, for example, some of the older RAM drives, random access memory drives. If you had a RAM drive, what we used to do is we would throw our temporary files onto the RAM drive. It was very fast, but when the computer got shut down, the RAM drive went away, cleaning the RAM drive, and then the RAM drive was rebuilt the next time the computer started back up. We have RAM forensics now. We have tools that will gather the RAM out of a computer, grab that information. If it's available, and in a lot of modern computers, grabbing the random access memory file or the boot start file is still there, which gives you a lot of information about what the person was doing in the session, because the computer wants to boot right back up and bring you back into your session very quickly. So a lot of your data and a lot of information is stored in that file, and that file can be looked at by forensic tools. Then your non-volatile, those are your hard drives, your standard storage drives. They are, you pull the cord or pull the power, that drive's not going to go away. It's still going to be available. The data is still going to be there. Your deleted data is still going to be there, etc. When you're processing volatile, basically the reason we have volatile is for speed. You can use a volatile storage container very, very fast. It runs out of cache or RAM. It holds a lot of the programming. So when I'm switching back and forth between my PowerPoint and my Excel, that's all going into my RAM. But again, on the newer computers, RAM is viewable, and RAM is something that we can collect off of some systems now, or most systems now, and we can do RAM forensics. So if someone is using RAM and it's volatile and it does kill, sometimes you can go right back in there and pull that information directly out of RAM, because it is still available. That file is there, and that file is there is built for speed. Your non-volatile, again, your hard disk, your drives, removable media. These are all types of non-volatile. So your thumb drives, CDs, things such as that are all non-volatile storage mediums. And non-volatile storage mediums are systems that typically will have your deleted information in them. You can find a lot of evidence on the end of these drives when fragmentation has happened and they've defragged their computers. And then just lost files, things that they forgot about or things that they never overwrote. And if it hasn't been overwritten, that data may be there. So in the slack of that drive, or in the unclean places of that drive where old data exists, you may have full systems. You may have a replicated or mirrored operating system. And then you have your file allocation systems. The file systems, file allocation table, FAT, NTFS, your new technology file system, dynamic disk, and EFS, some of the newer systems that are coming out. These are all operating systems that collect information in what we call the data, or excuse me, the system area of the computer. So in your system area of the computer, and I always refer to the file system as kind of like the Dewey Decimal System of the computer. So you have your Dewey Decimal System, and in your Dewey Decimal System you have your name of your file, you have the date of the file, you have all that metadata, all that information. That's all stored in this system area, or the file system area. But that data, that Dewey Decimal System, that Dewey Decimal card deck in front of the library does not have the book. The book resides out on the shelf, and that's our data area. So the file itself does not reside in the file system. The file itself resides out in the data area of the drive, which allows us to store information about the file in one place, very quick, easy read. So when I click on my file manager on my computer, it brings my files up very quickly, and then it gives me a pointer to where the first part of that file starts. So when I click on that file, it takes me to that part of the computer program and loads that computer program or that document or whatever it is that it's going to bring up. All right, and then lastly, things that happen to people: burnout and fatigue, extended analysis and searching, and then user interface. Burnout and fatigue, that basically comes from when people are just done being forensic examiners. Imagine spending 8 hours a day sitting in front of a computer staring at hex code looking for evidence. If that's your thing, you could do that probably for years. But if you're an outdoorsy kind of person, you may spend half your time looking out the window wishing you could get out and break free of your prison of your cubicle. So it all depends on your outlook. So there are some people, and there are some people that are made for computer forensics, and there's some people that just are not made for computer forensics. It's not for them. And you'll find police officers go to forensics, sometimes for job positions, sometimes for promotions. They end up in there and they just hate their life. And unfortunately, when you have people like that, you lose evidence because they're not as careful and they don't care to spend the time digging into resources and containers that might yield evidence. They're very happy to wash through a drive and say, yep, there was nothing there, or yeah, there was something there, and here it is, and I'm moving on. And then extended analysis and searching. Um, you got there's a certain point when you're done. It's kind of like the perfectionist that goes through and just continues and continues and continues, and you're like, it's good enough. It really is. It works. It's fine. Um, just move on. And sometimes examiners can't. They are stuck on a drive or they're stuck on a thing, and it takes a supervisor to come in and say, hey, you're done. And then user interface. There have been many, many, many tools that we've used over the years that just have a horrible interface. They're very hard to work with. They're not friendly. They take a lot of learning. There's a big upswing or learning curve creep to maintain. The next version comes out, it's even harder. Um, and some of the cost software coders don't learn from their mistakes. There's a couple of companies I'm very good friends with some of the owners, and their whole thing is you need to be a forensic examiner. You can't. Not everybody should be a forensic examiner. In fact, we're going to make our tool hard so it forces people to learn how to be forensic examiners. Some of those companies have been very successful, and a couple of those companies have died a horrible death because they just, their tool is just too hard to work with. All right. So again, this has been a real quick overview of the chapter. You got lots of good information in the chapter. Dig in as you have in all your other chapters. And again, you're going to be doing a live capture, and you are going to be doing a investigation using a forensic tool, a very friendly one. You will be going out and getting data. So I look forward to sharing that EO1 image file with you, and you guys getting a chance to kind of put into practice what you're learning here in chapter 13. And with that, I will say see you in your next chapter. Bye.